Section 5.1 had us start thinking about this idea of probability, but in Section 5.2, I want us to focus more on how we calculate these probabilities. So we're going to be talking about what's called a chance experiment. And a chance experiment is the process of making an observation when there is uncertainty about which of two or more possible outcomes will result. I roll a die, it could be one of 6 numbers, and so here that's a chance experiment because when I roll that die, I don't know what's going to happen until it happens. When we're looking at these chance experiments, we need to come up with the list or the collection of all possible outcomes of that chance experiment. And we call that the sample space. And it's usually denoted with a capital letter. Sometimes S is used, but really it could be anything, any capital letter. And when we talk about an event, we're talking about the collection of outcomes from the sample space of a chance experiment. So an event could be something like rolling an even number. So there would be a 2, 4, or 6. So it can be a collection of outcomes, or maybe a number less than 3. Well, that would be 1 or 2. So an event is just whatever it is that you are looking to observe. Now, a simple event is specifically when the event only has exactly one possible outcome in the sample space. So here, the simple event would be rolling a 2 or rolling a 6. How we use this is demonstrated here in these next few sections. So consider categorizing people who purchase a Honda Civic based on their gender and the type of engine purchased. So we have the event M that we'll use to say that they're male, F for female. And then there are 2 types of engines that you can get. You can get a hybrid or you can get a traditional. And you get to pick what letters you want to use unless it's already assigned for you, but you want to typically pick a letter that makes sense for what you're doing. So we're going to list out all the possible outcomes that could happen here. Well, a male could purchase a hybrid, so we would call that event male hybrid. A male could purchase a traditional, so that would be male traditional. Female hybrid and female traditional. That covers all the possible outcomes. Now the event hybrid, which events would that include? Well, that would be the male and the hybrid or the female and the hybrid. So I'm using those curly brackets or parentheses, the curly ones, and then I'm listing each outcome with a comma. Now the event male could be male hybrid or male traditional. So these events have multiple ways that the event could happen. So these would not be simple events. In example 5.2, we're looking at a coin game, and in this coin, you flip a coin twice, and if both coins are heads, then player 1 wins. If both coins are tails, then player 2 wins, and if the coin lands 1 head, 1 tail, the game is a tie. Is this a fair game? Well, let's list out the sample space. When you flip 2 coins, they could both be heads. You could get a head then a tail. You could get a tail then a head. Now, those are different outcomes here because you have 2 different coins. So you do actually have to list them both when you're listing this out. And then you could get both tails. So how would player 1 win? Well, that only happens when you have the event HH. Now, since all 4 of these outcomes are equally likely, here that HH is 1 out of the 4 possible outcomes. You can only do this when the outcomes are equally likely, but in the case of flipping coins, they would be. Now, the game results in a tie. Well, the events there would be heads, tails, or tails, heads, and so that's 2 out of the possible 4 outcomes, or you could simplify that to 1/2. So the classical approach to probabilities is when you look at your sample space and each of those outcomes in the sample space are equally likely, then the probability of an event E, which you would write probability and then E, whatever your E is, it could be words, it could be letters. The way you would calculate that is you would take the number of outcomes in the event E and divide it by the total number of outcomes, like we saw in example 2.